All right, good morning, everyone. I'm excited to introduce our next plenary panelists. So this panel is about understanding the individual in collective intelligence. I'm excited to introduce you to Modupe. It is her first collective intelligence conference. I'm really lucky to have her here today. So Modupe, I just met Modupe, I realized, but I know her well because my first year of graduate school was the year that she was on the market, and she was star of the market. And Harvard Business School, where I was starting, had her come and do all the events to explain to us as baby grad students how to basically become very accomplished researchers. So she's a professor at Columbia. I mean, grad school is so far behind you now. But anyway, so Modupe is a professor at Columbia Business School. And she studies how organizational environments affect the decision-making, especially stressful environments affect the decision-making that individuals do. So it will be very relevant for us in thinking about collective intelligence. Our next speaker will be Anita, so we're going to flop the order. Oh, we're not going to flop the order. We are. Anita, who you know well, I'm in charge. I get to say. Next will be Anita, who's our conference chair, so you know Anita. And then Nosh Contractor, who's been at Collective Intelligence before, who's a professor at Northwestern, and he's going to present on some really new, interesting research on Mars exploration, which is exciting. So please join me in welcoming, for her first time here, Modupe Akinola.
Well, thanks for inviting me, Melissa and Anita and the organizers. It is a treat to be here because this is my first collective intelligence work that I've done, so I'm excited to be able to share it with you. And as this group, we all know a piece of the reason we care about collective intelligence is that driven by the belief that when we get the blues, the reds, the yellows, and greens together, that some magic happens and some great team outcomes can occur. And so we know that for decades, researchers have been looking at what are some of the factors that can actually enhance group performance. And today is actually a very special day because I was talking to Anita and we realized that today would have been the birthday of Richard Hackman, who was her advisor, was the first person that introduced me to organizational behavior. So in some ways, I feel like we can dedicate this session to him. And much of the work that he did was looking at the context and the importance of context in terms of ensuring that when groups have processes, systems, and structures, that's when they perform well. Or group composition, when there's diversity, when there's variety in skills and intelligence, that's when groups perform well. But the majority of this research has focused on demographic characteristics of group members, or has even looked at psychological characteristics, but has not fully examined biological characteristics. And so since we're focusing on the individual, I'm going deep individual, looking at biology. Now, here's what I'm going to talk about, 2 papers. One paper is asking the question, do collective hormonal profiles of a group predict its performance? And in this paper, I'll be talking about collective hormonal profiles. I'll discuss that in a minute. Testosterone and cortisol is the hormones of focus. Is it? Focusing on testosterone and cortisol, and then obviously focusing on group performance. The second paper is what are some factors that can moderate the effects, like diversity, on group performance, and looking at testosterone only, but focusing on this idea of hormone diversity fit. So what are we talking about here? Here are my collaborators who worked on all of this with me. So here we were. We know there are many factors that can affect group performance. What about biology? And when we talk about biology, I'm talking about testosterone and cortisol. What's testosterone? Well, we all have it. It varies in each of us. It's associated with increases in physical and mental energy. If you look at primates who are at the top of the status hierarchy, they tend to have high testosterone. And so in humans, testosterone is linked to personality dominance, the desire to gain or maintain status. What about cortisol? You can think about cortisol as the stress hormone. Cortisol increases when we're in stressful situations, and generally speaking, when we're in these stressful situations and cortisol increases, we tend to want to flee from the situation. So that's testosterone and cortisol. And when we measure these, there are 2 ways of thinking about these hormones. There are your resting levels, which are typically, well, I'll do it this way because I clearly did not check my animation. You have resting levels, which are dispositional. they're pretty stable day to day to day. If I measured you today, it would be similar tomorrow, whatever. Then there's reactivity in a given situation. What I'm focusing here on is day to day, which is an index of your kind of dispositional trait-like dominance or trait-like anxiety. So there is some research done by one of my collaborators on this project where he has found that testosterone and cortisol work together. That testosterone has a positive impact on status attainment when cortisol is low. Another way to put this is when you want to win and when you want to beat everybody, it's helpful if you're not stressed. So this combination can be thought of as status drive without inhibition. And so he's found this in individual level performance. So if there's a high testosterone, low cortisol person will do well in a particular type of competition. We were interested in whether this extends to groups. So what do we know about those with high testosterone and low cortisol? They have a greater number of subordinates. They're perceived as more dominant leaders. They're respected by their peers. They're more popular within their social networks. And they engage in more competitive behavior and risk-taking. So they like to attain higher social standing. So we want to see if this hormonal profile will result in groups outperforming other groups. If a group with high testosterone and low cortisol is competing with another group, will they win in the competition? And our hypothesis is that this motivation will be beneficial, but the competing hypothesis is that when everyone is striving for status, they might be competing with each other, and that might result in reduced or impaired performance. So these were our two hypotheses. And this idea of too many cooks in the kitchen with too high testosterone, there is lots of evidence supporting that. So one of the things we wanted to look at were the mean hormone levels as well as variance in hormone levels. So when I talk about collective hormonal profiles, I really am just generally talking about the hormonal makeup of a group, which can be operationalized in a lot of ways. And as I've been talking about today, I'm focusing on mean testosterone and mean cortisol, but you can imagine lots of different combinations that could be the case in any type of collective hormonal profile work that's being done. Okay, so here's our setting. 370 MBAs, males and females from different backgrounds. These are first-year students. And our MBAs are randomly assigned to groups called learning teams. So groups range in size from 3 to 6, because some people could place out of the courses. And there wasn't much variance in terms of gender composition. So gender is used as a covariate in all of our analyses. And it's important to note that groups met regularly during the semester, but there were no formally assigned positions. So no one was always leader, whatever. Really, really kind of a random situation each time they would work together. And here's a study timeline. At the start of the class, they took a dominance survey, because one of the reasons I use hormones in my research is are they telling us anything above and beyond what self-reports might tell us? So trait dominance was measured, then 2 weeks later, took a saliva sample and measured trait anxiety. That saliva sample was assayed for testosterone. 1 week later in their operations management class, they started a week-long group decision-making task that lasted for a week. And that was our key dependent variable. And this was a web-based simulation. They were essentially simulating owning a supply chain, a blood lab testing, and they really just needed to win and make the most money in this exercise. And their goal was to maximize the profitability of this lab that they were running for the week. And they competed with each other because every day they'd know how are you doing relative to others in the class. And it ran for 7 days. It counted for their grade, so this idea of competition was really amped also because of the grade. And as I said, so the saliva was taken way before, so people weren't really, there was no connection. And the computerized exercise spits out different performance metrics, which became our dependent variables. We also control for time of day of saliva collection, which matters because certain sections were in the morning, certain sections were in the afternoon, and there's a diurnal cycle of hormones, and for the number of females in groups. And it's important to note that there wasn't a normative solution. There wasn't one way to do well. There were lots of things that groups could do to do well. So that was our key research question. And let me show you, we use a multi-level macro-micro model, which is the right way to do this analysis. I'll leave it at that. And it's much better than just using group means. And so here is our regression analysis predicting performance. No main effect of cortisol. So it doesn't matter your group level cortisol in terms of predicting your performance. No main effect of testosterone, but a significant interaction here. When we plot this out, what does it look like? On the x-axis, I have group testosterone. On the y-axis, I have performance. And we're going to be focused on the dashed line, which is low group cortisol, and high testosterone, which is what we care about. So here we see that when you were high in testosterone and low in group cortisol, that's when groups perform the best. So we do see that this individual level profile does extend to groups. And then the question was, what about within group variability? Is it just the mean? Is it variance? So we looked at that. Again, no main effect of the standard deviation or of testosterone or cortisol. The interaction was not significant when you look at the standard deviation. And when we include those in the model, you also still see this significant effect of mean levels of testosterone and cortisol. Additional research question, what about the concentration of high testosterone and low cortisol? And I call this my ode to reviewer 2. These are all the reviewer 2 questions. And so there's a way of looking at how each group clusters in terms of the numbers of people with high testosterone in the groups. Ran that analysis, no significant effects. Other things reviewer 2 is interested in. Well, these personality traits, did we see a significant effect when we looked at the personality traits, the self-reported measures? And with the self-reported measures, no main effect of anxiety, no main effect of dominance, and the interaction wasn't significant. So this is, again, a piece of why I use hormones in my research, and even when we included those, the interaction was still significant. Because the point is, sometimes hormones are getting at different behaviors than our self-reports are, and so we're able to get greater insights into groups and individual behavior when we actually also look at biological responses. Mics don't like me. I don't like mics either. And it seems as if these hormonal measures can capture potentially motivations outside of conscious awareness. Then we wanted to look at, well, these groups were diverse. Does diversity moderate the effects? I mean, a lot of the research that we see out there is about diversity and its effects on group performance. And there's so many different avenues or areas to look at. So diverse groups, we know that people are very different, so there are lots of perspectives that are being brought into consideration when there's diversity. And so you have to manage multiple identities, multiple cultural differences. And also, you're always monitoring the people's behaviors around you because you're not sure they're different from me. Are we going to think the same? So our idea was that these effects would be less pronounced in diverse groups. That was our hypothesis. And just to give you a sense of diversity in the groups, there's ethnic composition, and we could look at the numbers of ethnicities in the different groups, also nationalities, and we also have gender too, but I'm gonna focus on ethnicity and nationality. And here, when we look at nationality as a predictor, we see no main effect of nationality. We still see our significant interaction, and we don't see a significant three-way interaction. So diversity did not affect or influence our effects. Also, when you look at ethnicity, same thing. No main effect of ethnicity, our interaction is still significant, and no three-way interaction. So when we put it all together, it does seem as if this profile of high testosterone, low cortisol is related to group performance. This status drive without inhibition can heighten group performance. And it's about the mean. There's something about the average and not the variance that matters. And they're not influenced by group diversity, these effects. Now, I didn't buy that. I didn't believe that they weren't interested or affected by group diversity because we know from the literature that there's something there. So we started to think about this a little bit differently as we thought about diversity and our effects and what might we expect. So I want to share what we found in that analysis of these same data. So this is what our prediction was, that our effects would be less pronounced with diversity. But we said, let's think a little bit more about what we know about testosterone and how what we know about testosterone links with what we might know about diversity. One of the things we know about testosterone is that high testosterone outperform others. I've already said that. But too much testosterone can result in people within the group fighting with each other to win. What we know about low testosterone is that those who are lower in testosterone have a motivation to cooperate more. And that when you are low in testosterone and you are incentivized to cooperate, that's when you do best. And these studies have done things like tell someone you're competing with somebody versus cooperating with them and give you a GRE test afterwards. How well do you perform if you're low in testosterone? Well, if you're low, you perform well on the GRE when you know you're cooperating. When you're high in testosterone, you perform well on the GRE when you are competing. So that made us say, okay, this is what we know about testosterone. What do we know about the conditions under which people perform well with diversity? When you're high in diversity, you're focused so much on the intra-group dynamics that can detract from performance. There's less cohesion, less trust. But at the same time, these intra-group differences are the catalysts for the positive outcomes that come with diversity. So that's what we know about high diversity. What about low diversity or homogeneity? Well, you're so focused on the intergroup goals in low diversity when everyone looks alike that you can just focus on beating the other group. So that's when people do well. But when you are high in, or low in diversity and you all look alike, everyone wants to bond with each other, and there are these conformity pressures that sometimes result in groups not doing as well. We're like, oh yeah, we get each other, we're hanging, doing well, let's just go with this suggestion when it might not be the right suggestion. So if you put this together, what does it suggest? That if you're low on diversity and you're low in testosterone, you don't want to beat other people, and you don't have the intergroup cohesion to do really well. What about this cell? When you're high on diversity and high in testosterone, you want to win, and you're also different, so there's all this lack of trust and lack of cohesion and all this going on. So you would not do well as a group. However, if you're high on diversity and low in testosterone, you have the motivation to cooperate and you want to beat other groups. That's when we'd expect groups to do well. And then when you're low in diversity and high in testosterone, again, you want to win, but you don't have to worry as much about everyone's looking different, how are they thinking about me, and all that. So this is our theory of hormone diversity fit, which we were able to test with these data. And as I mentioned, these were our measures of diversity. And one way to look at these is one at a time. Look at gender, look at nationality, look at ethnicity. However, since we didn't have our significant effects with nationality, with the three-way, with the other data, we said maybe there's another way to look at this. And we decided to think about fault line analysis. And what fault line analysis does is it takes into consideration that each group has a different combination of diversity, and we need to think about that, not just the one-off measure of gender or one-off measure of nationality. And in this work, they found that when you look at this combination, it offers more explanatory power than looking at single item characteristics. So there's a calculation for figuring out the diversity of a group using fault line analysis, and so that's what we used in this analysis. And let me just give you a sense of the least diverse group. Mostly male, all white, mostly from the US. The most diverse group in the sample, still a lot of males, it's an MBA classroom. Some ethnicity diversity, but nationality diversity very, very broad. So you can get the sense of how different some of these groups were. So again, our question is, does testosterone, collective testosterone, moderate the effect of diversity on performance? And here is our regression analysis. And here we see no main effect of testosterone, no main effect of diversity, but a significant interaction. And does that interaction look like that box that we predicted, those boxes? It does. On the x-axis, again, is testosterone. Y-axis is performance, high and low diversity, dashed or not dashed lines. And this was our effect. So again, if you are low in testosterone, and low in diversity, you do well. If you're high in testosterone, did I mess that up? I did. Let me say that again. See, you were all paying attention. I love it. When you're low in testosterone and high in diversity, you want to cooperate and you all look different, you do well. But when you are low in diversity and high in testosterone, you all look the same and you all want to win and beat those other groups, that's when you do well. Just the point of what if we look at each of these alone? Not significant if you look at gender alone, not significant if you look at nationality alone, marginal if you look at ethnicity alone, which is a reminder, and I like to share this with grad students, if there are any grad students in here, don't give up hope if you find a not significant effect when you're looking at one thing in a particular way. There's so many other ways of looking at diversity, there's so many other ways of categorizing the many things we're interested in categorizing in our field, so it's all about FOW. If you're interested in diversity. Some other research questions. Is gender being double counted? Again, ode to reviewer 2. Because we have it as a control variable and also a predictor variable. And so looked at this standardizing testosterone within gender, and we still see our effect. Then they said, well, why don't you exclude gender from the diversity calculation, which doesn't make sense because gender is an aspect of diversity, but it's okay, reviewer 2, we'll do it. And we still saw a significant effect. And other research questions. What about other operationalizations? We were focused on mean, but what about maximum or minimum testosterone levels? Standard deviation, no significant effect. Minimum, no significant effect. Maximum, no significant effect, but still a significant effect with the mean. So there is something about the collective, the mean, the average levels, and not some of these other ways of operationalizing testosterone. So just to summarize, there is something powerful about the body and how we work together in groups that affects our performance. And we couldn't explain our effects by gender differences in testosterone or other factors. And so just in general, given the topic of this conference, there's so many other things to look at, one of which is what are the processes? What was going on in each of these different teams? And so we're doing more research on that, looking at mechanism, which we couldn't get at in the way we ran this study. But also, this is one context of competition. What about the context of stress? Would a different combination of hormones matter? Would we more likely see cortisol and another hormone that works well with cortisol, DHEAS? So as I think of collective hormonal profiles, I'm really trying to understand the context and what we might expect given our biology and how that might affect whatever outcomes we're interested in. And this is just focused on hormones, but you can imagine cardiovascular reactivity and changes and all that. And so future work, I want to look at cardiovascular collective measures to understand how groups work together, or the body and the groups work together. So that's all I have for you. Thank you very much for your time, and I'll pass it on.
So I'm just going to talk about a little bit of work in progress. And this will be kind of fun because some of these analyses I haven't even shared with my co-authors yet. So you can be at a real-time workshop on this. Starting with a bit of inspiration and also in part an ode to Richard Hackman, over 10 years ago, we published a study that was inspired by some of the work we had done in the intelligence community, trying to understand how we could get teams of experts to collaborate more effectively. So inspired by that, we created a lab study. We generated a counterterrorism task that we had teams come into the lab and work on. And so what we decided was to vary the expertise of the teams. So in some of our teams, we had subject matter experts who were deep level experts in the areas of the problem. Others were generalists. And so we were interested in how the teams would perform as a function of their expertise. So what we found, performance here was accuracy. How accurate were they at cracking this case? This is a case based on real world events, so we knew what happened. And so we were wondering how the teams would do. What we found was that the generalists performed about average, so they got some things right and some things wrong. They lacked some expertise to analyze some of the data, so we weren't too surprised about that. More surprising, however, was that the subject matter experts actually performed significantly worse. And so, we were kind of interested in why that happened and what we could do. So, being social psychologists, we then employed a 2x2. So we added a twist, which is we gave some of our teams a collaboration exercise, which sought to enhance their communication and the ways that they integrated information. So we either let the teams just go about doing the work on their own, or we made them spend 20 minutes doing our collaboration exercise. And so what we found then was that with the generalists, it didn't make any difference. They still lacked some of the expertise they needed to analyze some of the data. Subject matter experts, as I showed you, significantly worse without our exercise. But with our collaboration exercise, they did significantly better. And so what this really brought to mind and sort of set in motion were a set of studies where we started to think about intelligence in teams in a slightly different way. Traditionally, when we thought about intelligence in teams, we thought about it as a function of individual expertise. And so based on this, we would have thought that the teams with subject matter experts should have performed better than the generalists, no matter what. What we instead started to think about and started to work on with others, including Tom Malone, was this idea of collective intelligence, or the ability of a group to perform across a wide range of tasks as something that was demonstrably separate from the intelligence of individual members. And so, as we went about setting about to study this systematically, brought teams into the lab, had them do a bunch of tasks together, measured their collective intelligence as a function of how they performed on those tasks, and then predicted their future performance, and found that we could do so much more accurately than knowing the average IQ of the individual members. And in our initial paper on this, replicated this a few times. And I've gone on since to both continue to work on ways to measure collective intelligence and use it to measure future performance. And in a variety of settings, we do tend to find that collective intelligence is a strong predictor, whether we're talking about groups that just work together for an hour, student teams working together for a couple of months. We've done this in computer programming teams working together over 3 months. A couple years ago, looked at teams playing League of Legends. So, it seems that there is something about this ability of a group to work together that is important to try to understand and try to build more systematically. One important contingency variable here, and some work I'm doing with Ella Glickson, who's here at the conference, is how interdependently the team works. So you can have a highly collectively intelligent team, but if they don't actually work interdependently, it doesn't really matter. So that's an important caveat, and that's some of where we see some variability in the strength of the relationship between collective intelligence and future performance. Since then, we have set about doing a whole series of studies to try to understand now what builds collective intelligence. And so there have been a variety of things that we've measured in many of our studies. They kind of fall into two broad categories. The first, group composition, germane to the topic of this session. One thing that we've looked at a lot since our very first studies is the gender composition of the group. And so here's a graph that I keep adding to as we add to our data, as we've collected data over a series of studies. In our initial studies, we thought there was a linear correlation between the proportion of women and collective intelligence, but as we accumulate more data, it appears to be more of a curvilinear effect, where the purple line is average collective intelligence. Let me go back. And what we see is that teams oscillate around the average until they get to be majority female, when they're more consistently above average. And then when it gets to be all female, it goes back to being average. So what we see is that there is a benefit to gender diversity, but with a tilt toward having more women in the group. And one of the reasons for this relates to another feature we often measure, which is social perceptiveness. We give a lot of our participants the reading the mind and the eyes test, which was initially designed to screen people for for autism and autism spectrum disorder. But it turns out that this test is difficult even for people who are in the normal range of the spectrum. It asks people to look at 36 pictures of the eye region of the face and make guesses about what that person might be thinking or feeling. I won't put anybody on the spot by making you answer this. This one is playful. Although if you were thinking irritated, that's the most common wrong answer. And what's really fun is, I also teach these all-male MBA classes, and so I will put this up, and a lot of the guys will think that this person looks irritated, which often demonstrates the main point, which is that women on average score higher on tests like this than men, and that tends to explain at least part of the reason why having more women in the group improves collective intelligence. It's because it raises the average on skills like this. And what we find is that teams that are higher in social perceptiveness are also more likely to engage in some of the other processes that we find predict collective intelligence, such as more communication and more equal communication. Another paper that we just recently published looks at cognitive diversity in teams. And we once again find this curvilinear association where teams that are moderately cognitively diverse reach the highest levels of collective intelligence. So group composition seems to be an important contributor. So not necessarily individual IQ, but other aspects of the individuals that they bring into the team. Another whole set of things relates to group structures that facilitate productive group process. And so rather than go through all of the studies where we've looked at that, I'm going to actually just talk about a framework that we've more recently been applying to our data. We've over the last several years, have devised a platform for administering our test of collective intelligence, which enables us to collect a lot of other information about how the group members are interacting, who's doing what, how much effort they're putting in, and so on. And so we've more recently started to think about this in the context of Richard Hackman's framework for processes for group performance. So Hackman identified sort of three main process criteria for thinking about group interaction. The first relates to effort, simply how much work are people doing, how much effort are they putting forth. A second relates to strategy. So how good is the group at sort of dividing and conquering when they should, or all working together when they should? How good are they at allocating their collective efforts? And finally is the use of knowledge and skill, or how good is the group at picking up on who knows what and matching those abilities to the elements of the task that those people should be focusing on. So these are three things that with Pranav Gupta and other collaborators, we've been finding ways to operationalize using the data from our platform for administering our collective intelligence tasks. And so a question that I've been interested in, and my collaborators as well, is what is the relative contribution of individual ability and individual characteristics versus these processes, or together with these processes, and predicting collective intelligence. And so I've accumulated some data across some MBA classes that I've taught here, and I had the data to examine this question. And so this is just some preliminary analysis that we've done. So with this model overall, we were able to predict about 86% of the variance and how teams did on our collective intelligence battery. We had an estimate of individual skill on each of the tasks in our battery, and what we found is overall, the individual ability predicted about 6% of the variance in how they performed on the collective intelligence battery. Social skills predicted an additional 5%, so these things are being put in all together. So I'm talking about their unique variance. Gender diversity, so the kind of squared term of the proportion of women, predicted another 21% of the variance. Cognitive diversity, another 22%. So at this point, I've predicted a little over 50% of the variance overall in the collective intelligence. Now I'm going into those processes. effort, strategy, and knowledge and skill. Effort predicted another 23%, so how hard the team worked was predictive. Knowledge and skill use, 8%, and then strategy, another 15%. I see a lot of cameras going up, so I just want to say this is work in progress, so please don't distribute this widely. So what we have really is that about half of the variance in collective intelligence is predicted by the individuals in the team, and the other half, approximately, the group process. And of course, I know, reviewer two, you're out there. We got to look at the interactions. So I don't have all of my regressions done to put up like Modupe had, but that's definitely one of the directions we want to go in. Finally, I just want to point out something that keeps showing up in our research, which is that how team members feel about each other is not a strong predictor of collective intelligence in our studies. We have a variety of data sets showing that things like cohesion, psychological safety, and satisfaction, group satisfaction, are not strong predictors. And just, as a to connect with what Modupe was just talking about in her research, we've even looked at this on a physiological level. So some research that I've done with Maria Tomprou, who's been out there orchestrating a lot of our events here at the conference, and Laura Dabish, we've been looking at physiological correlates of collective intelligence. And what they really support is this notion that there might be these two different pathways to performance. So in these teams, we measured two sort of different physiological indicators. We looked at facial expressions and the synchrony in facial expressions across collaborators, as this is a good indication of mutual attention. We also looked at synchrony and electrodermal activity, or how sweaty people are, because that tends to capture shared feelings. So we wired people up, we had them collaborate, and so what we found is that synchrony in facial expressions was a strong predictor of collective intelligence, so this mutual attention piece is important. Synchrony in electrodermal activity was a strong predictor of group satisfaction. So having, shared feelings makes us happier to be working together. However, in this data, collective intelligence, again, was not related to group satisfaction, and synchrony and facial expressions was not related to synchrony and electrodermal activity. So there are these two different levels on which we're relating that are somewhat dissociated, which I think is important for those, I work in a business school and we look to apply these things. If you're trying to build collective intelligence in teams, it's not quite the same as some of the typical team building you might engage in, which is more focused on creating shared feelings often. Social perceptiveness played a role here. It again was associated with collective intelligence, and the synchrony of facial expressions was a mediator of that effect. So in essence, having people who are higher in social perceptiveness sort of fostered these shared mutual attention, which was an important part of this. So to close, what we find, over now a series of studies that are ongoing is that CI seems to form very early. Many of our studies are done with groups that are just meeting each other for the first time, but we also have studies of ongoing groups. We find similar relationships in terms of how CI is formed and what it's correlated with, the role of group composition and process in CI, the fact that it's distinct from the socio-emotional processes of the group is important. And then I didn't go into data that touches on these last 2 points, but a few other observations have been that it seems to be pretty stable over time. And in fact, I've acknowledged in public, to my sort of shame, is that sometimes I've measured collective intelligence in teams that are in teams courses where I'm trying to teach them how to be a better team. And I find that when I measure before and after, there's really no change. So I don't know, so sorry, Richard. And then it also seems to really provide the building blocks for the subsequent emergent processes. So teams researchers are very interested in emergent processes in teams. And what we are finding in some of our studies is that this quickly formed collective intelligence then shapes the degree to which these other things form. And so it's an important thing to consider in conjunction with those processes. So with that, I will thank you very much, and I'll hand it over to Nash. Thanks.
Hi, thanks again for giving me a chance to be here today. I'm sorry that I wasn't able to be here yesterday, and I was very jealous because of all the great presentations that I missed out on there. I'm going to talk today a little bit about some very preliminary work that we are doing, sort of out of this world, but actually very much in this world, on collective intelligence in space crews. So yes, the clicker does work. So obviously, this is also part of a team effort, and so it represents the collective intelligence of a whole lot of people. The three key faculty members who have been working with me on this are names that may be familiar to you: Leslie DeChurch, Alina Lungianu, and Suzanne Bell, who's done a lot of the groundbreaking work on team composition literature, and then a whole bunch of our students, as well as our collaborators at other universities, et cetera. I'll have the slide at the end again in case you need to either praise them or blame them after the talk is over. So the bottom line, the premise of this talk is that humans are on the verge of becoming an interplanetary species, and we are going to be habitating other planets. If you listen to Elon Musk, it's because there is just going to be a massive disaster. A meteorite is going to hit this planet Earth, and we're going to get obliterated, and the best chance of surviving as a human species, we increase the odds if we go actually habitate another planet or just at least hang around in space. If you listen to Jeff Bezos, his argument is a little different. His argument is that we need to go and become an interplanetary species because the resources on Earth are getting thinner and thinner, and the number of people are getting larger and larger, and so the best way in which we can continue to have abundance is if we get out of this Earth and go to other planets and so on. So there's obviously a lot of interest in NASA's journey to Mars, et cetera, and one of the things that NASA does is it tries to look at different kind of risks associated with different kinds of expedition, and what you see out here basically is that as we begin to go into long duration, long distance space exploration, teamwork all of a sudden becomes important. Teamwork was not important when you shot solo people like Alan Shepard and John Glenn out of essentially like a bullet out of a rock, into space, but it becomes much more important as we think of these long distance and long duration space exploration missions, and so they become as interested in teams as they were in radiation and gravity, et cetera, in the last decade, et cetera. One of the challenges is that if you plan to go to Mars, that trip is going to take 259 days by current estimates, in part because it takes a long time to get there, but then you have to stay on Mars for a long time before you get back into the orbital position so that you can sling back to Earth quickly. Otherwise, you'll be chasing the orbits to try to get back to Earth. And so it's not like you can get to Mars and then 1 week later decide this was a bad idea and try to catch a flight back. It's not going to happen there. In addition to that, the other problem is that as you get closer to Mars, because of the speed of light, having its own limits, is going to be as many as 22 minutes for a message from Earth to get to Mars and back, which means that unlike previous missions where mission control basically said the brains of the mission is in Houston and it's only the eyes and the ears that were on the spacecraft, now the brains also have to be on the spacecraft because it'll be 44 minutes before a spacecraft on Mars can say, we have a problem and expect to hear back from Houston. So all of these conditions, this is a quote that of a cosmonaut, Valerie Reumann, who says that in this case, all the conditions are necessary for murder are met if you shut two men in a cabin measuring 18 by 20 and leaving them together for 2 months. And we're talking about much more than 2 months. So the question then in terms of this talk is what happens to collective intelligence under extended periods of isolation and confinement? We're not going to go through this since we've already talked about this. So thank you, Anita, for switching to go ahead of me. I don't really need to talk about any of these issues. So this is really the sort of focus that we have out here. And if you think about collective intelligence in the context of space crews, here are some examples. You want to execute an extravehicular activity to repair a solar array damaged by debris, for example. You want to generate a strategy to create additional food using only items on board. You might want to decide how to allocate fuel or food rations to account for a longer than expected mission. And you want to negotiate a plan for how a government crew should support private industry profiting off Mars. These are all real situations that we are using as our activities in order to test some of these situations. So the question, of course, is, and this is really kind of funny because we did a session at the American Association for Advancement of Science, AAAS, in February, which got a lot of media attention. They actually did a dedicated press briefing just for this particular session that I had put together. And I had somebody from Bloomberg say, but are you collecting data from people who are actually going to Mars? And I'm like, duh, no, we're not there yet, but it would be nice to have a petri dish where we can collect data in these kinds situations. And of course, the dream would be that we would, or a nightmare, would be that we could manipulate people's isolation and sensory deprivation for hundreds of days while making them do complex and boring tasks, monitoring them 24/7 physiologically, and via audio, video, administering unlimited surveys. And could be Zimbardo's dream or a nightmare, etc. But wait, that's exactly what we are doing. And the place we are doing that is a place called HERA, which is the Human Exploration Research Analog. So this is a real facility at NASA, at the Johnson Space Center. You see the top right corner, that's the facility. It's a confined, isolated, confined space. You see these people are in there. They're making happy faces because right now they're just posing for the camera. This is not what the video shows when we actually study them. But this is an example of how we get data by putting these people who compete to get in there for 45 days at a time and are confined in this narrow space, and we can do literally, metaphorically, physiologically, and physically vocal clock them with all kinds of data you expect from a human being. How this gets past our brains being about 150. But again, we're not the only guilty people in this area. The Chinese euphemistically call their facility as the Chinese Lunar Palace. Russia has a similar facility called that facility. It really looks like the International Space Station. They put people in there for as many as 500 days at a time. It's called the Mars 500 mission. That did not end very well. The Canadian and the Japanese were literally ready to kill each other right after a brawl following these celebrations. That's a separate story. They're far somewhere. But what we did was we collected data from the HERA campaign. Again, HERA 30 collected data. What I'm going to report here is data from each of these missions, 4-person groups. So for somebody who is any kind of big data, it's really, really small data in many cases, but a lot of small data. The scenario was that they were supposed to be landing on an asteroid, so they were getting into this HERA, this capsule, and pretend like they were going to an asteroid. And as the days progressed, they were put into isolation, they were put into sleep deprivation, they were put into moments where the communication was delayed with back on Earth, which was going right to the left of that actually, but they had as many as 4 minutes of communication that would happen in the simulated mission. So then we also gave them, the part I'm going to talk about today is that we administered many team tasks of the kind that we would think of in a collective intelligence situation, which was measured creative thinking, problem solving, ethical collaboration, deliberation, and then coordinated behavior performance. And the tasks that we used were the generate tasks, the alternative uses of certain products, the survival tasks, the ones that were familiar with the appetite particles, negotiated tasks were the ethical dilemma tasks. How do you choose to go to Mars? Qualification, survival on Mars. How would we decide which private company profit how on Mars? The execute task was they actually had inside the HERA, but the parts of these are some of the campaigns. It's very real. They all had their little symbols. As you can see, there were some crews all female, some all male, some mixed. So this was campaign 3, this was campaign 4. So now for the results. So one of the things we noticed is that if you look at the execute task, which was the MMSEV task, where they had to remotely manage the robots on the asteroid, that was the one and actually the only task where they actually improved over time under isolation. So as you look at the days isolated, you see that in general, all of these are, all the crews that we are looking at here are all going up in terms of their execute performance. That's not true for generating new ideas. In that case, it declines with days in isolation, but rebounds towards the end of the mission. In space parlance, they refer to this as the third quarter effect. I think they may have stolen it from the sports metaphor, but the idea is that as you get close to the end, you're now more interested, you sort of, giddy things up again and get excited about it. If you look at the choose tasks, again, it declines with days in isolation, but only 2 of the crews rebounded at the end of the mission. And if you look at the negotiate performance, this is the one where we didn't really see any trends. In fact, we saw that most of the teams essentially were different from each other, but stayed stable over the entire duration. So isolation was not necessarily affecting them, etc. So conclusion 1 is that performance performance changes over time in isolation, and that while behavioral tasks seem to improve, perhaps with learning over isolation, anything that was intellective or creative, etc., and problem-solving tasks actually came down over isolation, etc. So the next question we asked was, do these crews exhibit single-factor collective intelligence? And here what we looked at was replicating very much of the kind of work that Anita and others have done, and found that while there was a C factor that loaded well on the first factor, there was also a substantial second factor, which turns out to be associated with creative thinking, that showed up as a separate second factor in this particular context. If you look at the histogram, you see that there's a lot of variability in the C scores associated with the different 9 crews. And so yeah, we collected these data multiple times during the cruise, so that's why we have 28 observations, even though we only had 9 missions. But you see that there is generally a sort of normal distribution, or at least some variability in it, et cetera. In fact, the C factor increased for 5 of the 8 crews over time in this particular context. So conclusion number 2 is that there was substantial variation in the C factor across space crews, but also across time, and there was some evidence for a second factor, which was the creativity factor, which loaded separately in some cases. So the last part I want to talk about is what predicts collective intelligence. And this, again, is obviously a recurring theme, because it's been true of all the presentations in this, and it represents in some ways the cells to society metaphor of how you can explain things in different ways. So we heard about how it could be explained by things like cortisol that are inside you. We heard about the individual attributes that Anita talked about. For some of you who might know that I'm interested in networks, you wouldn't be surprised that I'm going to talk about predictions of collective intelligence, or at least correlates of collective intelligence that are associated with interpersonal networks. One of the things we got to do is ask them questions such as this: the working relationships. With whom do you enjoy working with? Who makes tasks difficult to complete? Leadership tasks. Who do you provide leadership to? Who do you rely leadership to? And we asked them these questions recurring on several times during the course of the entire 45-day mission, et cetera. And one of the things we did was the non-network person's favorite network measure, network density. And so we simply took all these 4 networks and reverse coded hindrance and said, were the networks getting more dense over a period of time? And the answer is that if you look at these networks, they remain fairly stable. They decline a little bit over time, and they vary across different crews. So if you look at it from time 1 all the way through time 12, which is really the 12th data collection over the 45-day period, in all cases you see the density is beginning to fall off, et cetera, which means that people are not, the positive effect is deteriorating, the leadership is deteriorating, and hindrance, which was reverse coded, is also deteriorating in this case, et cetera. This is what we thought was somewhat interesting. If we take each of those missions and then now rank order these particular density plots with their C-scores, you find that there is, just eyeballing it, you see that there is some sort of pattern where those teams that had higher density across the board were the top-ranked teams, won, and the ones that had the lowest density were right at the bottom, et cetera. So you begin to see that there is some ordinal pattern between the density of networks and their collective intelligence. This again provides a little bit more of a statistical test that uses Kendall's tau and shows a significant correlation of 0.33 across the 32 observations. So bottom line, even something as simple as the density of the networks seem to be associated with collective intelligence. And so our conclusion 3 is that crews vary in the density of interpersonal networks, and that network density is significantly correlated with collective intelligence. So to conclude then, how can we design collectively intelligent teams? And so one of the issues we've talked about here and that NASA is interested in is to look at how we can take the science and apply it into it. When we first got funded on this, one of the first things I learned about it is to come up with good acronyms. I'm convinced that the only reason our project got funded was because we called our project CRUISE, which stands for Crew Recommender for Effective Work in Space. And I'm very proud that that was my main contribution to the proposal. And then when we began to put that together, we see that we can take these teams, and because we had all this high-resolution data over 45 days, we can use agent-based models to actually not use the models the way normally people use it, where you put parameters on your own, but estimate the parameters using behavior search algorithms or genetic algorithms from the data itself. So this is what we've been able to do, is build these models, collecting data at mission 1, and then the folks at NASA said, could you predict what will happen in mission 2? And we did a pretty good job of predicting what happened in mission 2. We took mission 1 and 2 and predicted what happened in 3, and so on and so forth. So this is sort of the way, the key part here is that we are fitting the model with real data and then using it to develop develop a dashboard to predict it. So in the case of the cruise project, we had a lot of different variables that we put into the model. We didn't have to decide how much each of these impacted it, but we had a bunch of variables, and this is where I relied heavily on people like Suzanne Bell and Leslie DeChurch, who know a lot more about the team literature on team composition than certainly I do. But our focus here was on predicting social relationships, which, as I've discussed previously, has an impact on collective intelligence, crew performance, et cetera. So these are the kinds of net logo models, which I don't think that the video is going to work in this case, but it's really cool because it did a remarkable job of being able to predict not just density in general, but who gets along with who thinks who is a hindrance. In one particular crew, it was remarkable that within the 10th day, there was one woman on the crew that everyone hated on, and she had no idea about it, and our model did a really good job of being able to predict that, and so on. And so that's really the goal of what we're trying to do here. And so the outcomes that we're generally looking for is that we wanted to start by descriptively better understanding what mechanisms are shaping the emergence of these ties, then predictively make guesses about how a given team will perform over time. And this year, what we've been doing in the HERA context is the folks there said, it's great that you're telling us that something is going to go wrong or that woman is not going to get along with anyone else, but what can you do to mitigate that problem? So starting this year, we've been doing things like crew pairing, where we're giving them ideas of, given the other members of the team, how would you choose the one particular person that you want to put in there, the only person that the Americans might get to choose on an international mission? Or in this case of a crew pairing, if two people we say are not going to get along, let's say that we say that Nikki and James are not getting along with each other, or we predict they won't get along with each other. What can we do to fix that relationship? Well, one thing we can do is not have them work together each other at all. So we essentially give them a cooling off period and then simulate and see what happens. Or what we could do is say, well, let them both work with Anita, and because they both love Anita, that'll give them a chance to get to know each other well and bond well. Or a third scenario might be that we do have them work together, but only on things that they do really well and enjoy, because success will breed a sense of bonding between them, et cetera. And so what we've been doing this year is predicting what will happen to the crew in one of these missions, and then also prescribing, and that's why we call it the prescriptive part of it, what we could do to fix a problem which we anticipate. And then so far I'd say we're running with about 75% accuracy, so we're not really that great at it. But we're also doing this in the context of a mission right now that we're collecting data in Moscow, where they're putting people into that NEK facility for 120 days, so they still have about 30 days in there. And so we'll see how we can extend the results from our 45-day studies in Johnson Space Center to that. So that's pretty much what our goal is, to try to enable teamwork far and near. And as I promised, here are the people who make this all possible so that I can come and talk to you folks about it. So thank you again very much.